Yes, science is amazing, but not to me though, cause I am sick of waiting. I've been patient, I really have, I've been reasonable. Now it's time to say what I needed to. Dear science.
All right, let's look at some advances in science that are coming any day now with Matt Dickerson, the host of Tech Time, the podcast. Hello, Matt.
G'day, how you going this morning, Nick?
Not doing too badly, although we did a story just before 9 o'clock on the problems that some of our local dairy farmers are facing, and you've got a bit of technology which is revolutionising the dairy industry. What's the story?
Well, revolutionising the dairy industry, but not in New South Wales. I'll get to that in a moment. Virtual fencing technology has been around in New Zealand for some time. There's about 100,000 cows in New Zealand that have got electronic collars. There was a story I did a while ago over in WA where they were using some electronic collars just as an electronic fence, because obviously around WA some pretty big paddocks out there, and putting a fence around is pretty difficult to do, so using electronic collars made sense. What they're doing with dairy farms, though, is they're using the electronic collars not just to keep the cattle within their boundaries, within their fence lines, but they're using the collars to actually bring the cows to the milking shed in the mornings ready to be milked. So rather than the poor old dairy farmer get up at some ridiculous time in the morning, 3 o'clock, probably the same time you get up in the morning, Nick, and get out there and bring the cows in, the collars are set to at a certain time to start using vibration cues, using sounds to move the cows in the right direction. So if they move in one direction, it makes a noise or vibrates, and they learn that they've got to go in this direction. There are some concerns, the RSPCA's got some concerns, because if the vibration and the sound don't quite do the job, there's also a little bit of electricity that might be put through the collar just to give them a real indication that maybe they're going in the wrong direction and they should turn around. So that's where the issue's been with it being banned in some states in Australia. So in New South Wales, Victoria, the ACT and South Australia, it's banned. But in Tasmania, there are people using it as we speak, using it every morning down there, and they think it's absolutely wonderful. Now, again, you are talking about the animals, and there's obviously sometimes a conflict between farmers and what they're doing with animals and, say, the RSPCA, but they do talk about potential acute stress response from the electric shocks. And I'm no expert on it, Nick, but I reckon there'd be a bit of a shock at 3 o'clock in the morning having a cattle dog nip away at my heels as well.
Aren't there dog collars that kind of do the same thing, that keep your dog within a certain range if you don't have big enough fences, that kind of thing?
You're spot on, and I don't think the RSPCA is happy about those ones either, Nick. But what I do like about these ones, though, is the electricity, the zap is the last resort. The sound and the vibration are what the cow will notice and take notice of, and then if it goes a bit too far in the wrong direction, that's when the zap will come. So I suspect that the cows will learn that certain sounds, certain vibrations mean they go in certain directions, and they'd learn pretty quickly that they don't want to go over there because that's where they got that shock last time, so I'm not going there again. The actual companies doing it, obviously they're saying it's a safe way to do it. They charge a fee. It's about $8.50 per month per cow. But the dairy farmers who are using it both here in Australia and over in New Zealand say that the efficiency that you get out of it and the extra time in bed, that'd be worth it alone, I think.
Fair enough. All right, now let's move on to a couple of other stories. We were just talking about trains and the problem with planes burning fossil fuels, of course. How far away might hydrogen-powered planes be, which, after all, would just burn and emit water vapour?
Exactly right, especially when the hydrogen, the big thing people always throw around, Nick, is that produce so much CO2 producing hydrogen, but what you want to do is produce hydrogen with renewables, and then you get a very clean propulsion method.
Yeah, green hydrogen, yeah.
Green hydrogen, that's right. So we've got a couple of companies that are out there doing this right now, flying planes with hydrogen as we speak. Dash 8, very popular plane in Australia. We've got Dash 8 used by one popular airline, and they've actually converted overseas. There's a company called Universal Hydrogen that's converted a Dash 8 to run off hydrogen, surprisingly enough with their name Universal Hydrogen. And they're at the point now where they've flown about 9 times up at 10,000 feet. They've got speeds around 170 knots, so they're getting there. And another company called Zero Avia has got a 19-seat Dornier 228. Similar stats. They've been flying about a dozen times so far at 5,000 feet, doing about 150 knots. So they're getting there. The real advantage for these flights will be the short-haul flights. The flights from Melbourne to Sydney, Sydney to Brisbane, those type of flights that are an hour and a half, that'll be the sweet spot. It's still some time away before we get Sydney to LA, those large flights, because you just don't have the energy density in hydrogen that you do in a kerosene or a jet kerosene, for example. The real issue here, Nick, is how you store the hydrogen. When you store it as a gas, it's easier to store, but as a gas, obviously the energy density is not that high. Storing it as a liquid is much better. You can store more in a small amount of space, but you have to have it under high pressure, and putting high pressure in big tanks, big strong tanks, is not conducive to putting in a plane because there's extra weight and there's extra pressure that you need there. So there's some challenges there they've got with hydrogen. I think hydrogen will definitely be used in trains, as you mentioned, long-haul trucks. I think hydrogen's definitely got a place there. In planes, it's a real challenge to get something. Batteries are heavy in a plane. That doesn't make it a great thing for flying, and hydrogen is not perfect either. But we're working on it, I suppose, is the bottom line here.
Yeah, it is interesting because both of these things, the batteries and the pressure vessel and the liquid itself, are heavy, way heavier than kerosene, which goes in, or avgas, which goes in planes, and just makes it not conducive to flying. So that's going to be a hard one to crack, isn't it?
Yeah, if you could store the hydrogen in something that wasn't so heavy and didn't have such high pressure, that'd be great. But again, as a gas, it's big, and on a plane, you're trying to conserve two things. You're trying to conserve weight and space, and neither of those things is really conducive with hydrogen.
Okay, just quickly, why is the South Korean superconductor such a big deal?
Well, superconductors are a big deal in general. I know I've only got about a minute and a half there, Nick, but superconductors basically allow electricity to flow with near zero resistance. When you consider in our electricity grid, we waste about 10% of the electricity that we generate in transmission. If we could have a superconductor with no resistance or near enough to no resistance, that would be fantastic. Now, we've been able to create superconductors at near absolute zero temperatures, so pretty cold, but you use so much energy keeping it at those temperatures, there's no net gain. And we'll be able to produce superconductors at high pressures, but again, you need to keep those high pressures up, which uses energy. South Korean scientists have come up with a product they call LK99, and they're claiming this to be a superconductor at room temperatures. So that's pretty exciting. That means you can build transmission lines, you can build maglev trains, high-speed trains you're talking about before. You can do all sorts of exciting things with room temperature superconductors, but the rest of the scientific world isn't quite convinced yet. They need to see a bit more data from the South Korean scientists.
All right, good on you, Matt. Thanks, mate. Talk to you next week.
My pleasure, Nick.
Matt Dickerson is the host of Tech Time, the podcast.